So you've probably gotten pretty good at solving quadratic equations by factoring, right? But what happens when you hit a wall? When those numbers just refuse to cooperate? Well, today, we're going to unlock the master key. This is a method that's guaranteed to solve any quadratic equation out there, and it's called completing the square.
Here's what we're going to cover. First, we'll talk about why factoring sometimes just doesn't cut it. Then, we'll dive into the magic number algorithm. That's the real heart of this whole thing. After that, we'll see it in action, work through some examples, I'll point out the common traps so you don't fall for them, and then we'll wrap up by talking about why this matters for your future in math. Let's do it.
All right, first things first. Why even learn a new method? Let's really dig into the problem we need to solve here.
So this is the big question, isn't it? You get a quadratic, you try your factoring tricks, and nothing. It's a dead end. So what now? Are you just stuck? Do you give up? No way! There's got to be a better, more powerful tool for the job.
And this is it. Think of completing the square as your universal key. It doesn't care if the equation is nice and neat. It's kind of like the brute force method that will crack the code on any quadratic you can imagine.
So let's get into the nitty-gritty. How does this universal key actually work? Well, it all comes down to a really simple, repeatable set of steps. An algorithm, really.
The entire game plan, our one and only goal, is to reshape the equation. We want to force it into this perfect form, a perfect square on one side and just a plain old number on the other. Why? Because once you've got it looking like that, solving it is super easy. You just take the square root of both sides.
Okay, so how do we actually do it? It's a 5-step recipe, super reliable. Step 1, get that constant term c all by itself on one side of the equation. Step 2, this is the cool part, find the magic number. You just take your b coefficient, cut it in half, and then square that result. Step 3, and this is super important, you add that magic number to both sides. Got to keep things balanced, right? Step 4, the left side of your equation is now going to factor into a perfect, beautiful square. And finally, step 5, just solve by taking the square root. That's it. It's a system that works every single time.
Now hold on. There is one really important rule you have to check before you even start step 1. This whole magic number thing, it only works if the number in front of your x squared term, your a value, is a 1. If it's anything else, say a 2x squared, you have to divide every single piece of the equation by that a value first. Do not skip this step.
Okay, enough talking about it. The best way to really get this is to see it work. So let's walk through 3 different examples, and we'll start easy and then ramp up the difficulty.
For our first example, we've got a pretty standard one. X squared plus 6x minus 7 equals 0. Now, you could probably solve this by factoring, which is actually great because it lets us check our answer and prove that this method really works. All right, let's follow our steps. First, we move that constant, the negative 7, over to the other side by adding 7. Next up, the magic number. Our b value is 6. Half of 6 is 3, and 3 squared is 9. And what's the crucial part? We add that 9 to both sides to keep our equation balanced.
So now, that left side, x squared plus 6x plus 9, factors down perfectly to x plus 3 squared, and the right side is just 16. From here, it's a piece of cake. Take the square root of both sides, just remember it could be a positive or a negative 4, and we get our 2 solutions, x equals 1 and x equals negative 7. See, it works.
Okay, on to the next one. This is where the method really starts to become essential. The equation x squared minus 4x plus 1 equals 0, well, you can't factor that one nicely. So now we need a new tool.
But we just follow the exact same process. Move the 1 over. Our b here is negative 4. Half of that is negative 2. Square it, and you get a positive 4 for our magic number. We add that 4 to both sides. The left side magically factors into x minus 2 squared, and the right side is just 3.
And now we take the square root. The square root of 3 isn't a clean number, and you know what? That's totally fine. We just leave it as the square root of 3. Add 2 to both sides, and we've got our answers. 2 plus the square root of 3 and 2 minus the square root of 3.
So for our last example, let's really push things. What if you get an equation that doesn't even have real number solutions? Guess what? Completing the square can handle that too.
We follow the same steps we know and love. Move the 5 over, find our magic number, which is just 1, and add it to both sides. But check out what happens now. The left side is x plus 1 squared, but the right side is negative 4. Uh-oh. But it's not a problem. When we take the square root of a negative, we just use imaginary numbers. The square root of negative 4 is 2i, so our final answers are complex numbers. -1 plus or minus 2i. This thing really can solve anything.
Okay, you've seen how powerful this is. Now let's talk about the mistakes. Knowing where the common traps are is the absolute best way to make sure you don't fall into them.
All right, listen up, because this is, by far, the #1 mistake I see people make. They forget to keep the equation balanced. It's so easy to do. You get all excited about creating that perfect square on the left, and you just forget to add the magic number to the right side too. You just can't do that. An equation is like a set of scales, you know? What you do to one side, you absolutely have to do to the other.
So, let's just recap the two biggest pitfalls. Number 1, unbalancing the scales, forgetting to add that magic number to both sides. Number 2 is a simple factoring mistake. The number that goes inside the parentheses, that's half of b. It's not the magic number itself. Remember that first example? b was 6, so we factored to x plus 3, not x plus 9. Big difference.
So, why did we spend all this time learning this one specific algorithm? I promise, it's not just a neat party trick for solving equations. This is a fundamental skill that's going to open up a ton of doors for you in more advanced math.
You know the quadratic formula? Ever wondered where it came from? It's not magic. You actually create it by taking the standard form of a quadratic equation, ax squared plus bx plus c, and applying this exact method, completing the square. This technique is literally the proof behind one of the most famous formulas in all of algebra.
And it does not stop there. I mean, look at this. Later on, when you get to something called conic sections, which is all about graphing circles, ellipses, stuff like that, you'll be using this exact same skill all the time to get the equations into a form that you can actually graph. So getting good at it now is going to pay off big time.
So, let's end on this thought. You now hold a key that can unlock a solution for any quadratic equation. That's a pretty powerful tool, but it's more than a formula. It's a way of thinking, of transforming a problem into a shape you know how to handle. So the real question is, what other mathematical doors is this going to unlock for you?